Hello everyone, welcome to your DA40 systems brief demonstration flight. Today we are going to be covering the DA40 startup, taxi and takeoff in the DA40 NG. We're going to be following the DA40 NG normal checklist on the Moodle as well as any relevant flows for the aircraft. So this is the DA40 then. So the DA40 is a T-tailed aircraft with winglets powered by Jet A1. The propeller here is a constant speed propeller, which is a type of variable pitch propeller that automatically adjusts its blade angle to maintain a chosen RPM. So the difference with this to a normal propeller is rather than maintaining this same angle for the entire flight, the propeller will actually adjust depending on what the best pitch is for the stage of flight. So for example, during a takeoff roll, the propeller is going to be more flat like this to get more air behind it, whilst in the cruise it's going to be more fine so that you can get a higher speed with less drag. And when you're in the feathered position like so, this is basically how it will lock in place whilst the engine is stopped. Here you've got your heat exchange and your vents for the engine cooling, and you've also got an engine inlet there. You've got your oil hatch here. This is how you can access and check your oil. And you've got more air intakes there. You've got your engine exhaust there, and then you've got your nose gear here, which is free cast ring. You might have a nose wheel fairing, you might not. It depends on the DA40. You've got your step for getting into the aircraft. You access the aircraft via the main hatch. You open it by pulling this lever and then lifting the canopy up. On the left wing, we come down here to check the gear. So again, we've got a fixed rear gear. Moving along, we've got our stall warner here. So this is a this will go off depending on the disrupted airflow. Moving along, we have the pitot tube here, which is how the DA40 gets its both total pressure and static pressure. And then we got our taxi and landing light on the edge of the wing here. We got our navigation light and strobe lights on the edge of the wing. We got static wicks on the edge of the wing, so we need to make sure they're attached before flight. And we got our ailerons here on the edge of the wing with a trim tab here, so that you don't have an aileron trim in the DA40, you just have a trim tab, as you probably saw in the PowerPoint. You've got your flaps operating here, so they are operated by a push rod system. Coming around, you got the tail, you got the skid marker here, which you need to check before each flight. Coming up here, we have more static wicks on the tail, with the elevator at the top of the tail rather than down below. And then you got a rudder here. Coming around onto this side, it's similar on this side. You've got your flaps, and then you've got your ailerons on the outside wing, with your navigation and strobe lights. Coming to the front, we don't have a stall warner on this side, it's only on the right wing, and we don't have a landing and taxi light on this wing. Coming along, again, we've got another exhaust there. We've got our two tyres there and our free cast ring nose gear. So we're going to jump into the cockpit and walk through the cockpit here at Shoreham. So jumping into the cockpit, it looks a bit more flashy than a PA-28 or a Cessna 172. We've got a nice new style cockpit here with two G1000s fitted. So we'll start down below. So we got a trim wheel here. So this is how we can operate the trim in the aircraft. So to go nose down, you push forward like so, and then to push nose up, you want to roll it back. For takeoff, we always set it at neutral. Then we got a emergency fuel valve, which is here. So in the DA40, the fuel only feeds from the left tank, as the left tank is named the main tank, whilst the right wing is named as the auxiliary tank. So during flight, we have to continually transfer the fuel to ensure it's balanced. So we do this via the fuel transfer switch up here. However, if the fuel transfer switch does break, we might need to open the fuel valve emergency to ensure we get a crossfeed from the right to the left wing. However, we would need to close this back to normal before the fuel in the right wing is empty. And then you'll also notice here, as we move up, that we've only got one power lever. We don't have a mixture, we don't have a prop lever, we don't have anything. So this is called a single power lever. And this controls something called the load. So we're not really talking about RPM in an aircraft like the DA40. We're simply talking load. And then by using this power lever, the FADEC, the fully automated digital engine control, that will set the mixture, the RPM, and the propeller pitch, depending on what we want and what's most efficient for flight. So we don't have to worry about that. Moving up, we have our cabin heat, so that's on, that is off. We got our defrost, which will go on and then off. And then we got our parking brake. It's ensure you get the right position, so lock is down, release is up. So we need to make sure we put it in, we need to make sure it's locked, which means the parking brake's on. The electric master is operated by a key, so on is the electric master on, and then start is the engine start. So when we eventually start the electrics, we only want to move it to the on position. Moving across, we've got our avionics master. Then we've got our essential buzz. Please check the DA40 systems brief for the usability of the essential buzz, but this is not for normal operations. This is only for electrical failure circumstances, but you would need to check the AFM for the conditions of use. On the left side, we have our engine control panel. The switch that is guarded is our engine master. To turn the engine on, we would simply turn this to on, and then we would start it via the electric master. To turn the engine off, you simply turn it off. You got your fuel pumps, which are used for takeoff and landing. And then you got your engine control unit A and B. So the A and B is basically just a redundancy feature. So we leave it in the auto position, so it will automatically put it in the correct engine control unit for the correct time of flight. So we just need to check that before we depart. And then we got the ECU test. So unlike a conventional light fixed wing aircraft, we don't do a run-up check in the DA40. We do, but rather than us pilots worrying about RPM drops or anything like that, we simply just press and hold this button like that, and it will run the run-up checks automatically for us. Moving up, we got our lights panel, so this is how you adjust the instrument lights and the floodlights. You also have our 4 external lights, so you got your landing light, taxi light, position light, strobe light. When it's like this, it's off. When you put it up, it's on. We also have an emergency switch. This is for if you have an electrical failure. This will provide electrical power to certain instruments for 30 minutes. Then you got your standby instruments here, so you got your airspeed indicator, attitude indicator, and altimeter. And then you got your standby compass as well. You got an emergency locator transmitter here, which should be in the arm position. If the red light shows, that means it's been activated. It shouldn't be activated. That's only to be used in an emergency. You got all your circuit breakers on the right side here. And then moving down, we've got our flaps. The flaps are electrically operated with the speeds placarded here. So 110 knots for the takeoff flap, 98 knots for the landing flap. Moving across, we got our pitot heat. So if we enter icing conditions or cloud, we would need to turn on the pitot heat like so. And then when our fuel is imbalanced, we need to press the fuel transfer switch. But we need to keep an eye on that because when the fuel is transferring, it won't just turn off. So we need to turn it off. And then we got our G1000 as shown. So I'm going to run you through the checklist until we get airborne now. So we're going to start down here. So pre-flight is completed. Flight plan is as required. We don't need a flight plan for VFR flying. We want to check our rear door is closed and latched, so it's closed, and our front canopy is closed and latched. The emergency fuel valve should be normal, and in real life there is a wire that will link through it, through that little spot there, just to make sure it hasn't been broken. The power lever should be idle. Parking brake is set on. Alternate air, which is this one here, that is on. That is closed, so it should be closed. Electric master should be off. Avionics master off. Essential buzz off. Alternate static, which is underneath here. It probably isn't modelled in the sim, but there's a little metal switch below there. That'll be off. Engine master should be off and guarded. Votor switches should be on auto. Fuel pump off. All light switches we want to check are off. Emergency switches off and guarded. ELT is armed. Circuit breakers we check are all in. Our flaps are up and we want to visually check that. That's set. Our pitot heat is off and our fuel transfer is off. So now we can turn on the electric master. So we turn that on and we should hear fan noises. Which we do. We can hear, as long as you can hear the system starting up, we can. The G1000 we want to acknowledge. And we should see two screens like that. We want to check the coolant light has disappeared, which it has. Fuel temperature, so we want to check the temperature is in the green. And then we want to check the fuel quantity. So fuel quantity should be as required for flight. We'd usually use full tanks. Then we need to check the fuel. So it should be as set here, so 9 and 9, so we got 18 gallons, so we need to check that the fuel there is set, so we can click reset fuel, and then we should be able to adjust that up and down, but I don't think that system's modelled, but there should be a left and right button here to adjust the gallons remaining, and then that'll allow us to know the gallons used in flight, our endurance and our range. Now we need to listen to our ATIS. So to listen to the ATIS, we would need to turn on the avionics master. So this will power up the avionics. There we go, the avionics have powered. So we would tune in the ATIS frequency for Shoreham, and then we would also tune in tower and approach up here. As I'm offline for today's flight, we won't do that, but pretend we have put the frequencies in there. So listen to our information and pretend we got information alpha and RQB 1025. You set that via the outer knob here, as you can see. Now we need to request start clearance. So Shoreham Tower, VATSky 01, information alpha, QNH 1025, request engine start. Startup approved, VATSky 01. Start clearance has been obtained, power lever idle, position light on. Engine start checklist. Backup. So we need to press the display backup, which will look like that. We then need to put engine instruments on MFD and engine system. Again, I don't think a limitation of the MSFS, but we need to have engine instruments like this on that screen and the system page on there, but it looks like it's only going to give us one. So that is fine, so we'll just set it like that. Propeller area, we need to shout clear. Okay, so now we're ready for engine start. We need to turn our avionics master off. We're then going to turn our electric master, not our electric master, our engine master to on. And we're going to wait for the glow to disappear. The glow will be on. The annunciators are normal. The glow is now off. We can now start our engines. Hold until we get 700 RPM. Release it. Oil pressure rises in the green. RPM 700 RPM plus or minus 20. And load 1%. And that is how you start the engine. Now we've checked all that, the guard can go on. After start checklist. Oil pressure is checked in the green. RPM 710 plus or minus 30. Warm up time, we need to wait 2 minutes, so we go to timer reference and we can start a timer for 2 minutes. Circuit breakers, we check, they're all in. Pitot heat. So we want to come to the system page, so we've got the electrical display up, and we want to turn our pitot heat on. We should see the amps rise, which it does. The annunciator disappears. Turn that off. The amps lower, and the caution comes on. We can clear the caution. Now we can turn the avionics master on, and we can turn the display backup mode to normal. So it should look like that. And we always want that on engine. Now we do the FMS setup. So how this works, we start on the top right of the PFD. So we want to set our frequencies for flight. So we want to set the current, we should have the active tower on. Then we want to set approach if we haven't already. We can set 121.5 on the standby. And we can also have an ATIS frequency on there. So put 121.5 in. On the nav frequencies, we'd set any nav frequencies we want and identify them. Then we come down to the bottom. We don't need a map or HSI for the P1. So you can have a map on, but you're not allowed it for the P1. Then you come back, go PFD options. You can turn on the wind, so I recommend option 1. A DME if you've got a DME, so we can put that on. And then bearing 1 and 2 can give you GPS, nav1, nav2, or ADFs. We won't need that for today's flight, so we can leave that off. And then the CDI, you have 3 options of this. You have the GPS, Localizer 1, or Localizer 2. We will set it on Localizer 1 and we'll set the runway heading. So today the winds at Shoreham are 240 degrees, so it's going to be runway 20. So we're going to set a heading of 200 degrees on here. Can be quite tedious to get around sometimes, but generally we want to set runway heading. Okay, so we've got heading, course of 200 set. This is basically so we can see what the runway's doing, and it helps us after departure. We can then set any ADF, so we tune the ADF and switch it by pressing Enter to transfer, and then we want to make sure the DME is on the right mode if we're using a DME. We're not today, but you can set that up. Transponder, so we need to be on standby whilst on the ground. And we can be at 7,000 if we're not being given a code by ATC. Then we can press timer and reference. This is the screen you want to keep up whilst you're flying. So this will tell you your speeds as well as the timer. Then when you come across, you want to check the MFD. So you want to check your fuel is in balance. And you also want to check the fuel down there is correct, which it is. And then you rotate the FMS to aux. You want to move this to system setup. If the G1000 was complete, then there would be a few more pages. But we want to check all of these are correct. So 6th of October 25, 12:30 is the time. Check it's in UTC. And then you want to check magnetic degrees. You want to check nautical miles and knots, feet and feet per minute, Celsius degrees centigrade, gallons per hour, weight we want to, and this is a prime example, weight we want to be in kilograms, and then going over here we want the altitude buffer at 200 feet, and we can set the we can set them to on. I don't think you can in this system, but then you want these onto auto 8.33, and you can set 1800 feet on the runway length and enter. Then we can go back to maps. Again, for the P1, we will actually leave it on the auxiliary page, as you're not, or you need to leave it on the auxiliary page as you can't use a move map. So that is the FMS setup. Then we want flaps. So we want to check the full travel. So we're going to put it at takeoff. Wait for the green light to extinguish. White light. That means it's set. So we want to check that. Then we set it at landing. So 2 lights means it's moving. 1 light means it's set. Check it. Back up to takeoff. And back up to up. That's checked. Altimeters, so we want 1025, 1025 set. Transponder is 7000 standby. Engine T's and P's are in the green. The oil pressure might be a bit low because of if the engine RPM's low. And then taxi clearance we will obtain. VATSky01, request taxi. And then we will obtain our taxi clearance, we'll put taxi light on. We're going to release the brake after looking left and right clear, and we're going to put a bit of power on to get us moving, idle the power, and check the brakes. The brakes work. Good. So we can now continue taxi, and you don't need a lot of power to taxi. Fast walking pace is what you'll be told to do. So we're going to taxi out, and we're not going to do our taxi checks whilst we're on the ramp, and we can set the view a little bit closer. So checking left as we go into the taxiway, and then we can perform our taxi checks here. So as we go around the corner, numbers increasing, ball out to the left, attitude is stable. So this is about the taxi speed you want. You can maybe go a little bit faster, but generally you don't want it to be going too fast, as you risk a taxiway excursion if you're going too fast. As we go around the left corner, we're checking numbers decreasing, ball out to the right, attitude is stable. As we taxi, we can see the wind's coming from the left, so we're going to put left ailerons into wind. As you can see, that's the stick there. We can put the left ailerons into wind. In a straight line, you can go a little bit faster than a fast walking pace. Again, you want to keep it just nice and stable on the taxiway. Nothing too fast, nothing too slow, just a steady pace. And again, don't be chopping and changing power. Can kind of just set the power and hold it. There we go. We're going a bit, we're speeding up a bit now. So we're just going to reduce the power. And we can see as we reduce the power, the speed's going to be maintaining. and we might slow down a bit. But if we want to slow down, the first thing we want to do is reduce the power. We never want to brake with the power on. So as we come up to the corner, we want to slow down for the corner. And you'll see that the power checks must always be done into wind if we can, as this will provide the most amount of airflow into the engine for the power checks, which basically gives us the best possible conditions. So the power checks are done in the little bays off to our left hand side. So we're going to slowly brake to bring the power back, and then we're going to bring it back, and then we're going to bring it around the corner, and we want to do it into wind, which is about there, and then we just pull forward a bit just so we don't block the taxiway, but I don't think anyone's going to get through there anyway. So idle the power, set the parking brake. Okay, so we're now at the holding point, ready to commence our power checks. So we're going to go through the before takeoff checklist now. So we don't have a power checklist in the DA40, just a before takeoff checklist. So parking brake is set on, rear door is latched, front canopy is closed and latched, door warning lights is off. The door warning light would come up as a annunciation on the PFD even. Fuel temperature, engine instruments are all in the green. Fuel temperature in the green. Circuit breakers are all in. Trim is set for takeoff. Flaps, we use the takeoff flaps in the DA40, so takeoff flaps are set, and visually check each side, they both are. Flight controls, full free movement. So how we do the flight controls on a light fixed wing aircraft is we go full forward, keeping it full forward we go fully to the left. Then we go fully to the back left, fully to the back right, fully down, and centered. So we're checking the four corners of the flight controls, and that's fully free now. Then we're going to check power lever is idle, which it is, and then we're going to do ECU test. So we're just going to check there's no one taxiing behind us. So we are going to hold. So we're going to cover the brakes just in case. So we're going to hold the ECU test. So we should get AB fail on the PFD, and then the prop will cycle. So we're increasing load. And it's going to cut and change, and we're still holding the ECU test button, we're not letting it go. So that's on its second cycle now, and that's going back to idle, and that should be settled. Yeah, that's settled, so we'll let go of that now. So the ECU test has been performed and the annunciators are now off. If it still said ECU A and B fail, that means you've got an issue. So now we need to test the voter switches, so this will change it from ECU A to B. So we'll change it to A. You should feel a little jump. T's and P's still in the green. And I don't think you can switch it to B, but you would turn it back to B and it would do the same thing, it would jump a little bit. Back to auto. Engine T's and P's are still all within the green. We'll check the system as well, that's in the green. Pitot heat, so it is 15 degrees, so pitot heat remain off. Transponder is 7,000, standby. Fuel pumps we set on, and departure briefing. So our departure briefing will go something like, it's going to be a full length takeoff at runway 20. Rotation will be at 67 knots, climbing initially at 72 knots. At the end of the runway, we're going to turn right 10 degrees, and then at 300 feet, we're going to Reduce the power to 90%, which is a requirement for the NG. And then we're going to climb at 80 knots. Once we're over the coast, we will resume own navigation. We'll set the bugs climbing up to 2,000 feet. And we'll set a heading bug. The wind was coming... Where's the windsock? The wind's coming from the right, so we're going to need to just go a little bit right of centre line, so like 205. So that's that's our departure briefing, safety briefing. So if you have an engine failure or need to stop for any reason, we'll close the throttle, apply brake and come to a complete stop on the runway. If we have an engine failure after rotation, if we have sufficient runway to land on, then we will. If not, we will pitch for our best glide speed, which is 88 knots, look for a field, preferably 30 degrees within the nose, and then perform our crash actions. That is our departure briefing, and that's our before takeoff checklist complete. So we're now going to release the parking brake and pull up to the holding point. So we need to go forward a bit, then we will turn round. And we'll pull up to the holding point. So this is Kilo 1. So we will hold at Kilo 1. Okay, so set the parking brake. And we want to perform our ATPL flow. So, approach path is clear, runway, clear. Transponder. Code is set, out. P, pitot heat. Below 10 degrees we would turn on, but it's above, so we'd keep that off. And lights. Landing light, strobes, taxi light off. VAT Sky 01, holding at Kilo 1, ready for departure. Cleared for takeoff, runway 20. VAT Sky 01. Okay, so we're now cleared for takeoff, so we'll line up on the runway. Approach path is still clear. Okay, so wind's coming from the right, so we do right ailerons into wind. There we go. Hold on the brakes, right ailerons into wind. So we set full power whilst holding on the brakes, because this is the power jack, 100%, T's and P's holding in the green, brakes released. Okie dokie, so airspeed is building, RPM is set, T's and P's in the green. Waiting for 67 knots. 67, rotate. And we're pitching to hold it, and we want 72 knots, so we want to pitch up, and we're going to start that trim. So it's quite a steep angular climb to begin with, but only to 300 feet AGL. So it's showing because it's sea level, 300 feet. Okay, so we're going to reduce back to 90%, turn right by 10 degrees for the power line, 90%, speed check, positive rate, flaps up, and we're just going to let that speed increase to 80 knots now. At 80 knots, we're just going to raise the attitude to hold it, and we're going to trim. So we're selecting, holding, and trimming. So as you can see, we're holding the load at 90%, and that will adjust the RPM. We don't touch the RPM in this aircraft, and we're simply just going to climb on this heading. Make sure we're nicely in trim at 80 knots. So flaps are up, engine T's and P's are in the green. Landing light can come off, and we're in trim at 80. And we're just making small corrections if we need to. We're climbing quite nicely here at 80 knots. Okay, above 1,000 feet, fuel pump can come off. Fuel pump off. That's checked. And the aircraft should just naturally climb when it's in trim at 80 knots. It's not the most efficient climb as it's not RVY speed, but 80 knots is the climb speed in the DA40, which is a little bit different to a PA28 due to the or Cessna 172, because we're not climbing at VY due to the really low speed of VY. So we like to keep our speed a little bit faster in the DA40, which does give us a little bit of a reduced rate of climb, but it does provide us with the best efficiency. So we're about thinking to level off now, so we got 30 to go. So we're going to lower the nose gently. To hold it, we're going to let that speed increase, bit of trim forward to help us. And we want about 110 knots in the DA40. 5 knots above our speed, 5 knots below our speed, we're going to slowly reduce to 65% load, which should give us 110 knots. And we're just going to get ourselves trimmed down. And we can use 110 for the navigation. And as you can see, we've got the aircraft trimmed. So, that is how you depart in the DA40, your startup, taxi and takeoff. Please now complete the DA40's knowledge check on the middle under the induction page, just to check your knowledge of the DA40. Thank you for watching, and I'm sure we'll see you on the P1 course very shortly.